Welcome to iLecture Online. Now we're going to take a look at implicit differentiation and try to find a higher order derivative of that particular equation. And what we're trying to find is we're trying to find the second derivative of y with respect to x. In the next video, we're going to find the second derivative of x with respect to y of the very same function. So you can compare the two. So how do we do that? Well, in order to do that, since we know that we're going to take the derivative with respect to x, we're going to take the derivative with respect to x of both sides of the equation. So on the left side, we take the d dx. That means the derivative with respect to x of 4x squared minus 2y squared. And on the right side, we take the d dx of 9. The right side is easy, right? The derivative with respect to x of 9, that's 0. But what about the left side? Well, we get 2 times 4, that gives us 8. X to the exponent 1 less, x 2 minus 1 is x to the first power, times the derivative of x with respect to x. That's called the chain rule. Again, normally we don't do that because dx is simply 1, but just so you know that that's really what we should be doing. And then minus 2 times 2, that would be minus 4, y to the first power. We don't have to write to the first power. But now again, using the chain rule, that would be dy dx. And here, it is very necessary to write that because otherwise we don't get it right. That is indeed what we do, right? We use the chain rule. It is, we get 8 times x to the first power times the derivative, what's inside. If you want to put parentheses around that, is what's inside the parentheses. So we need to write dx dx, and there dy dx. And then here, the d dx of a constant is equal to 0. So what we're going to do next is realize that this is equal to 1. So we can say that this is simply 8x minus 4y dy dx. That's equal to 0. And now, what we need to do is we need to solve that for dy dx. So let's bring the 8x across. We have minus 4y dy dx is equal to minus 8x, and then if we divide both sides by minus 4y, we get dy dx is equal to minus 8x divided by minus 4y when we bring the minus 4y over, and that simplifies to 2x divided by y. So what we're finding here is that our first derivative of y with respect to x is equal to 2xy, or 2x over y, I should say. So now what we can do is take the second derivative. So now let's come over here. Now we're going to take the second derivative, which is the d dx of the dy dx, which is equal to the d square y dx square, which is how we write the second derivative of y with respect to x. And so that would be equal to the d dx, careful here, the d dx of 2x over y. So what we're doing here is we're taking the derivative of the first derivative dy dx, the derivative of 2x over y, because that's dy dx. So now we see we need to use the quotient rule. So this is equal to the denominator y times the derivative of the numerator with respect to x. So the derivative of 2x with respect to x is simply 2 times dx dx, but we don't need to write that. Minus the numerator, 2x, times the derivative of y with respect to x, and that would be dy dx. All divided by the denominator squared, which is y squared. And that would be the second derivative of y with respect to x. Of course, we're not done yet because we need to replace dy dx by what dy dx is equal to, which is 2x over y. So that means that this is equal to 2y minus 2x times dy dx, which is 2x over y. And the whole thing divided by y squared. So in the numerator, we want to use the common denominator. So what we're going to do, and let me move this over just a little bit because I didn't leave myself enough room. There we go. So what we're going to do here is on this one, we're going to multiply this times y and divide by y. So now we can see we have the common denominator here. So that means that this can be written as 1 over y. We can pull out the common denominator, and we end up with 2y squared minus 2 times 2, which is 4x squared, all divided by y cubed. Y squared. I got ahead of myself because now we bring this y down, and this can be written as 2y squared minus 4x squared divided by y cubed. And that is the second derivative of y with respect to x. I think this pen is dying on me. But that's how we do that. So when we do implicit differentiation, we go ahead and take the derivative with the specific variable we want. First, the first derivative on both sides. Then we solve the equation for dy dx, which is what we want. Then we take the second derivative by taking the derivative of the first derivative. And so that means the d dx of 2x over y, which is what dy dx was equal to. Use the quotient rule. We end up with a dy dx in the result for the second derivative. So we need to get rid of that and write it in terms of what we got when we did it for the first derivative. And that is how we find the second derivative with respect to x of that particular equation.